Well, welcome everyone. I'm looking forward today to talking to you about the concept of making products with data and artificial intelligence. The idea of data products has been around for quite a while, but more recently with the advent of artificial intelligence, what's possible has just grown exponentially. And I'm hoping to give you a variety of ideas to think about in this space. So I'm going to cover a couple of different topics. I'm going to talk about some ways that organizations are enhancing existing products, some ways they're creating brand new products with data and AI, some of the conceptual considerations you want to keep into account as you design your own, some of the technical considerations, and I'll finish with a few thoughts on the path forward. So let's start with existing products. One example I love is for the company Wayfair. In the old days, they were a cataloger. And in more recent times, of course, like most, they've moved online. One of the things they sell is a whole lot of home furnishings. And one of the challenges, especially online, is understanding how those home furnishings would look if you were to bring it into your own house. And so what you see on this picture is in the top right, there's an image and there's a little line down the middle. On the left is the original room's picture. And on the right is the AI enhanced picture of what that room could look like with the decorations that you've chosen. And so you can, slide back and forth very quickly, very easily to see how your room might look with the products that you've chosen. Now, the beauty of this is it makes it very easy. I could go check out some other furniture. I could ask for a different color. And instead of waiting on a designer and possibly having to pay for that to be generated, I can quickly see where it is and how it'll look and maybe make a purchase decision. But equally important, and you can see here on the web app, all of those products are real products that you can buy based on that photo. So I could say, give me the whole room, or I could say, just give me the couch and the table. The point is they've come up with a way to embed AI within their sales process that makes it easier for customers to check out what their products will look like and easier to buy. I think it's a great example. Insurance companies are doing a lot of work using AI, particularly image recognition. A tornado or a hurricane moves through an area. What do? Well, first of all, it can take several days, depending on what type of disaster it is, before people can actually get back into that area to assess damage. However, you can send a plane or a drone over top of those areas and take pictures pretty quickly. And so what some of the insurance companies do now, as soon as a storm moves on or a fire goes out, they're sending drones up. They're taking images of the properties and they've trained models to do a quick assessment in terms of the extent of that damage, total loss or just needs a new roof, et cetera. What that then lets them do is cut an initial check to a homeowner very, very quickly, even before the homeowners had a chance to see their own damage. It's a terrific customer service tool. Now, of course, they're still going to send adjusters out to finalize those quotes. But if, for example, it's obvious that a $500,000 home is burnt to the ground, you can be pretty sure you're going to have to be shelling out $400,000 to $500,000. Go ahead and send that out. And then as you have to go through the details to see whether it's actually, a $550,000 rebuild or a $505,000 rebuild, you can work through it. Similar technologies is happening with car auto wrecks. You can upload pictures of the damage on your car and get a quick adjustment as well. But these are great because it means that the customers are getting faster, better service, quicker money. The insurers will be able to take action quicker and understand the risk that they're under, for example, when a whole neighborhood gets hit by a disaster. And one of the key themes that I see in terms of those that have been most adopted are where a company integrates AI within existing functionality in a mostly seamless fashion. So here's a picture from Adobe Firefly. And obviously creative types for many years have used Adobe's products to generate marketing material, ad copy, et cetera. And they're often specifically not technically oriented analytics, data science, AI type of people. But they're using AI extensively now. And it's actually a very easy step for them to take. So for years, you'd always be able to search on keywords for stock photos. Well, now they've just embedded generative AI where you put in a prompt and it generates images. So there's slight difference between what kind of keywords you might put to find an image versus what kind of prompt you might do to generate an image. but it's substantively the same thing. And the interface itself looks pretty much identical. It's just what really changes for the most part is what you add into that prompt box. So this is an example where they were able to get a huge level of adoption very quickly because it just seamlessly fit within that product. So it's really some good stuff. And some of the biggest transformations, Google recently has rolled out what some have called the biggest change to Google's search engine functionality in a couple of decades, since like 2000, 2001 timeframe. And what they've done, they've gone from the right side, which is what we're all used to. You do a search and you get back a bunch of links, to what's on the left. They initially called it, I think it was Search Generative Experience when it was in the pilot and the initial testing. I believe now they've renamed it AI Overview. The point is, instead of returning those links now, it'll actually do an AI pass on top of those links, try and summarize what those core links are telling you and provide that at the top. And in fact, it can be difficult to find the traditional search results. You have to scroll down quite a bit. They're basically downplaying those now. And that's a huge fundamental change for Google. Now, one of the keys to this that's been pointed out is the way Google gets their money today is by showing you a link, often sponsored. They got paid to show you the link, and then you click on the link. Google gets paid, and that person you clicked on tries to get paid. How does that model work then if a lot of people read the AI summary and say, I have what I need, and they don't click through to those underlying pages? That could be a problem for both Google and their underlying partners. But there's time to work that out. It's just it's interesting to see such big changes made. But there's still some work to do. Generative AI, it's based on the training data. And when you're surveying links, you're going to get back high ranking links. It's really looking for popular links still and summarizing them. And what can happen is, in this case, the popular answers or the most browsed answers will come to the top. And they can be, for example, an Onion satirical article in the one case that had talked about eating rocks, but the AI didn't know it. It just knew it was a popular article, so it added it in. In another case, it talked about adding glue to pizza. Where that came from, you never know. So you have to be a little bit careful. And over time, with some of the techniques that are being evolved, and I'll talk even a little bit about that later, that'll get under control. But it's definitely still a new and in development technology. So let's move on to creating new products. So each of the prior things were an existing product where AI and data was able to somehow enhance it. What are some of the new products getting created? Well, one that I love is this company that has completely fake models that you can utilize for your campaigns. And they even say on their website, the highlighted green, these models do not exist. So this is iteration one. Obviously, further iterations will make it better and better. But for as cheap as a rollout, I think it was $29 a month, you can have your own fake models. And this, there's probably the early versions will be a little bit glitchy and all, but soon this is going to take off. And you think about it. I want to do a photo shoot. I'm a small business. I can't afford to fly a model and a camera crew down to a Caribbean island for a photo shoot and then possibly have to wait 2 days for some bad weather and rain to pass to get the nice sunny beach shots that I need. You can go out and do these all virtually, where the island images are virtual and the models are virtual, etc. This can also be great for social media influencers to not have to spend as much on getting themselves different places. Now, it can also be abused. You already read about social media influencers that go out and fake where they are, renting a private jet on a tarmac and pretending that they're somewhere that they're not. But this kind of product is going to take off. And one of the cool things here, you can even upload your own pictures and become the model. So I could, for example, put my head on, say, a young bodybuilder's body and try and make myself look different, obviously for a satire campaign, but cool stuff. There's also video generators now in a similar vein. You can go out and generate videos on demand, and they're really coming along very fast. Now, today, I think the one that I have on the picture here is a company called Runway. I believe they were about 30 seconds you can get, but of high def video. But in this case, this is a screenshot of a prompt that was a giant humanoid made of fluffy blue cotton candy stomping on the ground and roaring to the sky with a clear blue sky behind them. And I'll be honest with you, I don't think I could have come up with a better match to that somewhat crazy prompt myself. And I'll bet a lot of artists couldn't either. But the point is, you can come up with crazy ideas and generate this video, and it's relatively inexpensive. So sure, there is some risk that actors and photographers and all could lose jobs, but these products also enable creators to do all kinds of different things. You know, realistically, was anyone going to go create a bodysuit of this fluffy blue cotton candy monster and try and make a 30-second video? You know, probably not. But if you can do it for a couple dollars, you may. And so there's still jobs being generated on the flip side for those that are building this product, maintaining the product, providing customer service, etc. Now, synthetic data. This is a topic that's become huge. And it was big before generative AI, but generative AI actually takes it up another notch. So in a traditional data sense, let's take electronic medical records. They're very sensitive to work with. And there's all kinds of rules and regulations. You have to be very careful. If you have a set of real electronic medical records, a large set, you can create fake medical records probabilistically that will match all of the properties of those underlying data sets that don't have the HIPAA and privacy concerns that they would have. And so this is exciting. They're using a lot in the medical field where more people can do research using data that is statistically accurate, but not real. Let's take a couple other examples. Automobiles, self-driving cars. Some of those models have been trained in early stages in video games like Grand Theft Auto, because in Grand Theft Auto, it's not completely photorealistic, but you do have roads, they're twisting, they're turning, there's signs, there's other cars, and you can teach a lot of the basics in that completely fake environment. And one of the really cool examples I heard is, you know, facial recognition algorithms are notoriously buggy, don't work very well. Well, to fix that, you could take 10,000 pictures of me from 10 angles with 10 levels of light, with 10 hairstyles and 10 facial hair mixes, as an example. But it's just cost prohibitive. No one's actually going to do that cost-wise, and no one's going to want to sit for that many photos. But what research showed was you can upload images of me, a few images of me, train AI to create my image, ask the AI to generate fake images of me from 10 lighting levels, 10 angles, 10 hairstyles, etc., and then train a facial recognition algorithm on those 10,000 fake photos. And ironically, the model will better recognize my photo in real life. So if used appropriately, the synthetic data can actually provide extra privacy and reduce cost and speed development while getting things that are more accurate. It's kind of amazing. So I think we're going to see and continue to see products rolling out offering synthetic data. And even data products, you know, they change the game in terms of companies sharing information in a mutually beneficial fashion. Now, I like to argue that a lot of things that are called data products are really analytics products. People are buying analytics, not necessarily the raw data. It's the analytics on that data, but let's not quibble with that at this point. But you know, a good friend of mine heads up a major initiative at Walmart called Walmart Illuminate. And what they've done, you know, they've built very sophisticated internal analytics products. And they've turned some of those outwards so that companies can access it themselves. And this is mutually beneficial in a couple of ways. First of all, Walmart's getting revenue by allowing access to these reports. They've already built them for their internal purposes, so the incremental cost to turn them externally to subscribers isn't that high. And if the suppliers, you know, if the manufacturers supplying them their goods are able to get more efficient as a result of those reports, that also helps Walmart. On the flip side, those vendors that are selling products into Walmart to put in their stores, they're getting access to data they can't get elsewhere, right? They don't have Walmart's in-store data. They're able to look for other niches within the Walmart data sets that they might be able to target. And if they can then do a better job of stocking the shelves with their own products, that helps them make the case for Walmart to get more shelf space. So again, a nice mutually beneficial scenario here. In this case, it's largely some traditional data, but a net new product that wasn't available. And I'll finish with one that's out there, back to it still needs no work. This is a nice comical one. Anyone who's been in the South will recognize Buc-ee's. If you don't know about Buc-ee's, go click on it. It's basically, you know, a massive cross between a Walmart, a convenience store, and a Cracker Barrel. But here I am standing with the Buc-ee's mascot who was there one day. And let's just see how this played out. So I passed it to an image product that'll assess an image and tell you what's in it. And if you notice here, it gets some stuff pretty well right. It's talking about here that the number one guess is that this is a man standing next to a mascot. And that's pretty much dead on. Now, as you work your way down, you'll see another high probability is a cartoon of a squirrel. Well, it's obviously not a cartoon, but furthermore, Buc-ee is a beaver. He's not a squirrel. In fairness, I think a lot of people who didn't know that Buc-ee was a beaver might interpret that as a squirrel. But the point is, it sounds pretty good. These products will then go down even further. Here's a description getting further down in. It says, image, we see a man standing outdoors. So obviously that's wrong. We're not outdoors. We're in the store. And then it says, I'm in my early 40s. I can tell you for whatever reason, I'm lucky. Every image interpreter I've passed my image to consistently underestimates my age substantively. I'll take that mistake, but it's still wrong. But then it says I'm wearing a plaid shirt and blue jeans. Perfect. It also talks about there's a thing resembling a cartoon squirrel standing next to me. Very good. But it goes off the rails again by saying that the mascot's clothes look similar to mine. I see zero similarity between my clothes and Buc-ee's clothes. And then it talks about, we're sitting there, with a green grass beneath our feet and such. Obviously wrong. What I'll say is this, though. It's such a big image. It's possible that the lights could look like clouds. Clearly, the poles could look like trees. If the model's already decided that we're outside with a ground that smooth, about all it could be is sand, dirt, or desert, something, or maybe a big rock of some kind. So it's not too bad, but still some work to do to get these to work better. But it still, to me, is amazing how much they can do. So let's turn our attention now a little bit to what can we do in terms of conceptual considerations, things that you need to be aware of if you're going to try and make use of these kind of products. So first, a big question, is generative AI legally fair use? There's lawsuits all over the place related to the use of images and text and so forth to build these models. And it's a dicey area for sure. I'm going to throw on a little bit of a contrarian view for you. If I go to a university and I study art, or I study music, or I study to be an actor somewhere, what is a huge part of the curriculum? They have you review past photographers' work, past artists' paintings, past actors' movies and plays and such. And the whole point is that you're learning about what they did and why they did it, and you're seeing how they do it. And over time, you're going to develop your own style. You're going to develop your own painting style. A lot of times, whether it's an actor or an artist, they'll actually say, this person and this person heavily influenced me. And you can actually see that in what they do. But at the end of the day, we're still effectively borrowing something from every movie we've watched, or every book we've read, or every image we've looked at. And our own brains are synthesizing all of that, much like these models are. So we've ingested training data, we're generating output. We've looked at maybe, let's say, tens of thousands of pictures, maybe a couple thousand books, whereas these AI models have looked at virtually everything that exists. So one argument I would make is, I'd say generative AI could be, quote, stealing a little less from every piece of training data than we humans do. And so I don't think that we necessarily can say that what the generative AI is conceptually doing is much different than we. At the same time, we can't go too far. So there's been lawsuits, like way back in the day, Vanilla Ice got sued for sampling a little too much of a David Bowie song. You can't just copy either. And so this is the distinction I would say. As we get to the legally fair use, we're going to have to monitor it. You're going to have to be very careful as you implement these models into your products to make sure that you don't do it in a way that's going to get you in trouble. But we should hold the generative AI algorithms to the same standard that we would hold people, not a higher standard. The simple fact that they ingested a piece of content, it doesn't mean it's going to be misused any more than the fact I looked at someone's picture means that I'm going to go just copy that picture. Now, another concept to be careful about is with all of these models, context is absolutely critical. So I saw an article about a model that had been trained on a variety of things, including in this case, it would look at this picture and it's going to say it's two women, they're playing tennis, they're wearing a white skirt, etc. Now, if I asked it, did the woman just hit the tennis ball? It's going to come back probably with a 99% probability saying, yep, the woman just hit the tennis ball. Separately, if I say, is the woman just about to hit the tennis ball? It's probably going to come back and say 99% yes, because the individual assessment of those in context of just that question is totally believable. The problem is, as hopefully many of you have already figured out, it's obvious in this picture she either just hit the ball or is just about to hit the ball, but it's impossible to be both. And in order to answer the question, we can't do it from this picture. We would need two consecutive images so we could tell if the ball's coming further or closer to the racket. This is the kind of context that AI today is still not going to be easy or good at handling. And if you think about it, building these image recognition models is incredibly difficult to begin with. It could be equally or even more hard to help it understand all of the context and to know when not to take the most probable answer and when to ask for more context or say that it doesn't have enough information. And so this is one of the big challenges. There's also a lot of concern about ethics of AI and analytics in general, but obviously we're sitting here. So if you're going to release a product, it has to be ethical and safe. But the reality is any given type of algorithm might be ethical in one set scenario, not another. So let's take autonomous vehicles. Today, it's still not considered ethical to unleash 100% autonomous vehicles on highways at rush hour time. There's too much that can go wrong. And if there's things that a car doesn't know how to do, what's it going to do? All right, it's going to cause a wreck. Here's a picture of a massive multi-million-dollar piece of very dangerous farm equipment, fully autonomously working through a field. These are available and in use today. And the reason is the context of this environment is very different. You've got a huge piece of equipment with all these sharp blades and such. Yeah, very dangerous, but it's in a field by itself. There's not much else around. It's got cameras constantly monitoring. And if it ever sees anything it's unsure of, it stops. The farmer gets a message on their app and it's asked, what do you want me to do? And so the farmer can look and it might say, hey, you know what? I just see a weird reflection of a cloud in a puddle. Keep going. Or the farmer might say, wow, it looks like an injured cow somehow got out there, tells it to stop, and it'll stop, wait till the farmer comes out. So in this case, there's no danger in the equipment just stopping if it gets confused until someone can clarify it, whereas in a car on an interstate, there is risk. So you have to also, as you're developing these products, think about the specific areas and specific use cases they're going to be utilized in, and it's entirely plausible that the same exact product or the same type of algorithm powering that product could be perfectly fine in one case, but not in the other. So you have to examine the individual scenarios, not just a specific type of algorithm. And another big issue is the transparency and explainability. A lot of these AI models are not easy to understand. So in the image space, there's been a lot of cases of algorithms identifying seemingly well things like, say, cancer in X-ray films, but then it's found that what it was actually identifying is, every hospital or piece of equipment puts a little stamp on that X-ray, and it was identifying that it was from a cancer hospital by the stamp. That's what was getting its attention, a cancer hospital stamp, not anything in the actual X-ray. So obviously, that's not good. So part of what we've evolved now are these scenarios where I have a tree frog recognition algorithm. It takes, iteration after iteration to get this algorithm working. Now to diagnose, how's it making that decision that it is or isn't a tree frog? I take an image, and you'd have to do this with multiple images. And again, you go through many, many iterations. You gray out parts of that image at random, as you see in the middle, and you see what the probability that it's a tree frog is. And after you do a whole bunch of those iterations, you can eventually hone in on which parts of the picture are identifying it as a tree frog and decide, is this legit or not? In this case, I'd say it looks legit. In the case of those X-rays I mentioned, what was getting highlighted was the little stamps in the bottom corner, which obviously are only about where it was, not whether the film had cancer. And last, one context to think about, especially as you're building products, is that large language models are a lot more than generative AI. What's gotten the attention the last few years are the generative capabilities of large language models, and they're certainly very powerful. But there's a couple others. One is interpretation. And this is part of every generative AI. Even when you think you're asking for generative AI, what's the first step? You type in a prompt. What does that language model have to do? First and foremost, it has to interpret and understand what you asked for to then go generate your answer. So this interpretation is a massive and important capability. There's also summarization, that Google example of the new search, the new AI overview. It's taking pieces of information and it's not probabilistically generating you an answer as much as it's looking at some existing things that thinks contains your answer and then just organizing them or summarizing them. And so that's, for example, when you're doing summarization, you get much lower chance of having mistakes because you're not asking it to create an answer. You're asking it to organize the information you've given it into an answer. And then there's translation. This is huge already in the computer programming space where it's accelerating the updating of legacy code to new code by starting with an automatic translation that then people can debug much quicker than having to go and type the code from one to the other. And I've already seen an ad for a phone that has a screen on both sides with a built-in translation app where if let's say I'm in Japan, I ask a question in English to my phone and in virtual real time, it's going to spit out verbally and in writing in Japanese to the person looking at the other side of the phone. So a lot of really good stuff. So what I always encourage is don't think about large language models as generative AI. Think about generative AI as one of the maybe the best known capability of large language models, but do not forget about the interpretation. That's behind even the image generators have to interpret your prompt to then generate an image. So with all that said, let's talk for a couple of minutes about the technical considerations you need to think about. And these are actually also similarly non-trivial. So the first thing is hallucinations. I hinted at this earlier. This is a screenshot of a Guardian article. And they were noticing about a year ago that there were a ton of fake Guardian articles. And when I say fake, it could be that it's a real Guardian author, but not a real article. Other times you literally have examples. It's a completely made up author with a completely made up article with a completely made up link, but it sounded plausible to be a Guardian. And they dug into this. And here's what you have to remember. People mistake when you ask a ChatGPT or a Claude or another of the models a question that it's somehow by default looking up and giving you the correct answer. It's not. It is literally word by word or even letter by letter, generating probabilistically an answer for you. Even if it had the exact answer, it may or may not present that to you. It's going to probabilistically do it. And that's where things go off the rails. You're getting a probabilistically generated answer. And in the case of The Guardian, for example, probabilistically, it would be very likely that this author would have written an article such as this. And if it was on the Guardian site, it would have had a URL that looks somewhat like this. And so here's the key I'll leave you with on this one. It's that it's all actually a hallucination, right? Kind of like Oprah, right? Every answer is effectively a hallucination because generative AI by default is not looking up an answer. It has been trained. It has parameters. It interprets your prompt and word by word generates you an answer. So what I always say is instead of being frustrated or concerned about the wrong answers you get at times or some pieces of the answer being wrong, be amazed at how often it actually gets it right because it's just making it up. That's what blows me away. Generative AI is just making things up probabilistically, gets it right actually far more often than it gets it wrong, particularly for topics that are very well documented. But never forget that it's still hallucinating things. I think people struggle with this with text much more than images. I don't think people mistake that the fake image is fake. Our brains know it and we logically know it, but people do get confused by the image. So what this leads to is, here I asked, tell me the history of the world in 50 words. As soon as my answer came back, I asked it again. So these are seconds apart. And what you'll notice is the answers are vaguely similar, but they're not at all the same. And they might even have some errors in them. And you might say, well, how is this? Because I asked the same question. This is another important point about generative AI you have to understand. It doesn't literally give you the most probabilistic, the most highly probable answer as it generates each consecutive letter or word. They found that if you actually do that, it comes up with very dry, non-human sounding answers. So they inject some randomness. Maybe say 80% of the time, it'll take the most probable next word or letter. And then 20% of the time, it'll randomly choose between those ranked 2 to 5 or 2 to 10. If you use some of these tools, there's sometimes a temperature setting. That's what this is adjusting. How much randomness do you inject? Problem is, after you've generated the first 3 words, there's a new mathematical representation of those 3 words to determine the probability of the 4th word. So as we're adding randomness, by the time you're through a couple words, you've almost certainly had at least one word be different already. And from there, they're going to diverge very quickly. Hence, vaguely similar, but not identical answers, even to the same question from the same person seconds apart. But it gets a little bit worse. When I wrote about this on LinkedIn, someone said, well, Bill, remember, you're in the same session and there's session memory. So that person asked the exact same question twice in a row, got 2 incredibly different answers from mine and that were similarly, also similar. The key is that this was a different context. So my answers were basically history of the world from a human civilization perspective. It's not inappropriate. It's a fair way to interpret it. These answers are history of the world as a planet. Again, reasonable way to interpret it, but very different from human civilization. So this gets back to why you have to be careful with generative AI as you're building products is even asking the same question, you won't get the same answer yourself. One after the other, different people can get different answers. And as training data gets updated, probabilities can change and the answers can diverge a lot. So you just have to be cautious with that and think about where can I use this where it's safe to have that? And luckily there are places. And so the first place I saw doing something like Google's doing with their AI overview was Amazon. They were I think it's rolled out fully now. It was a prototype for a while. You know, I go to buy a product. I look at all the different reviews. I look at some good ones, some bad ones. And I'm really just trying to synthesize what's the general trend. Well, Amazon basically had an AI routine, go over those reviews and then summarize in a paragraph the key themes of the reviews, as well as highlight some things that are or are not consistently positive or negative about the product. Here's the key. If the summary you see is slightly different from the summary I see, it really doesn't matter as long as they're both generally correct. But furthermore, I can promise you that Amazon's not updating these every time a person hits the page, because that will cost way too much. At most, every time a new review comes in, they'll update the review summary and then show that same summary to everybody until another new review comes in. My guess is, particularly for products with lots of reviews, they update it on some much lower cadence, maybe every 100 reviews or once a month, whatever it is. So the fact that there could be different answers every time, most people are still going to see the exact same answer. And if I send you the same link today of something I saw, you're most likely going to see what I saw. And as long as it's mostly correct, we don't care that there was 1,000 other similarly vague and correct answers. So it's just a matter of thinking it through. Now, one way that's very popular for addressing the idea of hallucinations is what's called retrieval augmented generation. And what this is about is saying, instead of simply probabilistically generating an answer from scratch, first, I want you to take into account some very specific information I'm feeding you. And now we're into interpreting that prompt I gave, ingesting the documents I gave, and now more of a summarization than a generation. That's why the summarization is so important. We're now saying, you know, instead of making up an answer about how that math works, I just gave you a couple math books, ingest those, and give me a summary answer. Now, the key is for that to work, you can't literally just pass it a book as one big piece of thing. You have to break it into pieces, either by section, by paragraph. There's a whole art to that. Point is, you get it back in there, it makes it retrievable. And so my prompt is put into a mathematical representation. It'll look up in the database it's generated from these documents what's most similar and bring it back. And what they're doing now is even combining these. So there's the retrieval augmented generation has been likened to an open book exam where you don't study ahead of time. I'm just telling the algorithm, here's what I want you to base the answer on. Fine tuning is more like a closed book exam. This is what a lot of companies are doing, where I say, I'm going to take an open source model or a commercial model, bring it in-house and tune it on all of my internal documentation so it learns my business context and language better. That's been likened to a closed book exam, right? The answers you get out of it are only going to be based on what it was trained on. Well, Raft is kind of a combination. You still fine tune on your data as much as possible. But on top of that, if you have documentation that you know is relevant to your question, you also feed it that. And these two things together will really help to hone in the probability that you're going to get errors. So there's all kinds of progress here coming along. All right. So let's finish with a little bit on the path forward. Where is it going from here? And what kind of things should you be thinking about as you think plan products out for the next 12, 18, 24 months? So first, the newest things to hit the market are what are known as multimodal models. And I saw a demo video. I think I have the link here for you of Google's latest, and it is impressive. You walk around with the phone with the app up, and it's in real time, both talking back and forth with you, interpreting the video. And in this specific video, if you go out and click on the link, you'll see that they asked, what is that? And identified it was a computer speaker and talked about the components. They pointed it out a window and said, where am I? And it recognized they were in a certain neighborhood in London based on the skyline. They pointed to some computer code on the screen and asked what the code was doing, and it came out with an answer. They had it do a poem. And then what I found the most fascinating was they asked at the end, they said, hey, I think I left my glasses somewhere. Did you see them? And the model said, oh, yeah, back by that computer in the other room, because it was keeping the context of that conversation, was able to find those glasses. So these multimodal things bring everything I've just talked about together. It's not just a language model or just an image model or just a interpretation model. It's all of those in real time, generating new text, potentially generating new code and images, interpreting things. It's a whole nother level, and the product potential for betting on top of these is going to be massive. I think another thing for it is that open source is going to be a huge player in this area. Meta released their Llama model, and it is nipping at the heels of the best commercial offerings right now. And it's totally open source. So I saw one article claiming that it was about 1/20th the cost to run things through the Llama model in the traditional approach compared to one of the commercial models. Now, there's other companies releasing open source models as well. And part of the beauty of this is you can take that open source model and put it internally and then do your tuning like we talked about with the wrap and own it free and clear. So I think open source is going to be a major player here. And if you're going to build products, I'd heavily consider building on top of these, both for cost perspectives and also a risk perspective, because I think some of the commercial companies could struggle mightily to continue to get the fees they're getting when there's free models available that do the same. And we've already seen that play out in other parts of software with open source. I also encourage you to think about these foundational models are like operating systems, meaning, in a world today, 99% of computers are either working Windows or Apple. That's just how it is. On phones, all phones are either going to be iOS from Apple or they're going to be Google Android. Now, similarly, most laptops, a lot of people, you might have a Dell laptop or a Toshiba, whatever laptop you have. Those aren't really differentiated. They're just foundational, right? If I get a Dell laptop and I throw on Windows on it, I can do pretty much everything I need to do. And sure, there's people with certain custom criteria where Windows or Apple will work a little bit better. But for most people, you get all that you need. No one's building their own custom operating systems for the most part today. It wouldn't make sense for a company to do that because the ones that are out there provide everything that you need as a foundation. You don't need to build your own laptops because the ones out there provide everything you need. You similarly don't need to build your own foundational models. You don't need your own large language model, your own image recognition model at all, because there's going to be a few foundational ones out there that everyone can leverage. And just like you pay a license fee for the Windows system, you'll pay a license fee to use that, but it's going to be so much cheaper. The value is on all of the applications that you put on top, right? Your phone, you don't care that it's Apple or Android as much as you care about the apps you can use. And most apps you can use on both. Similarly, you're not going to care so much about the foundational model. There'll be multiple to choose from that'll be fundamentally the same, but it's what can you build on top of those things to add value. That's where the secret sauce for products are. So partner with the foundational models, build on top. Also, based on these talks, don't force things like generative AI where they don't belong. So let's go back to that. The way even with the raft methodology, you can rein in hallucinations and such. There's places you cannot afford to make up answers. If I go to a hotel website and I say, what's the room availability and rate for tonight and what's the cancellation policy? I do not want a probabilistic answer generated that's telling me what typically would be the room rate and the typical availability and the typical cancellation policy. You want to be doing the traditional, let's go look up in this system. What is the availability? What is the actual rate we can offer right now? And what is the actual cancellation policy? So if you start to mix and match some of these AI things into places you shouldn't, a lot of people are trying to put in chatbots. There's a lot of types of chatbots that you do not want generative AI doing anything but possibly summarizing some information that you've collected. Which brings us to how things are evolving. So with LLMs, for example, we're going to see ensembles, meaning if I submit my same prompt to 3 different foundational language models, I'll get 3 different answers. However, the things that they match on, that they probabilistically all came up with, are much more likely to be true. And when they make something up, they're much less likely to make up the same thing. So when I see something consistent across multiple models, I can be that much more confident. When I see something that's only in one of them, I have to be much more cautious. So we can ensemble to get better, but also the idea of plugins. This is an example of one from Wolfram. Again, generative AI doesn't do math. It's not a calculator. It's going to probabilistically answer it. When you want an answer, back to the interpretation component of the language model, oh, in this prompt, one of the things Bill asked for involves math. I'm going to pass that part of it, this prompt, to this plugin to actually compute the math and give me the answer back. So our hotel example. Well, Bill wants availability and room rate. I'm going to the reservation system to look up the availability and rate, get that back. He wants a cancellation policy. I'm going to go in over to the system where those are stored. I'm going to bring that back. He wanted to know what people generally think of the property. I'm going to run the Amazon Google style summary of reviews on that, because I don't care if it's perfect or not. Now I'm going to add a summarization routine on top of all of that to put a slight narrative that it says, hey, Bill, looks like the room will be 150. You can cancel anytime until midnight, and the hotel's pretty well thought. By having various plugins that handle different things, that's going to be secret sauce. There's a lot of room for products that do plugins. I see coming down the road chemistry plugins, biology plugins, plugins for all kinds of special stuff that does an amazing job. And you're parsing out a prompt to multiple different places and bringing it back. And again, doing all of that parsing and consolidation is another big challenge, but it's already being tackled. And so I'll leave you with the thought then that as you think about applications and products to build using AI, it's about how do you take and mix the best of the generative, the best of the summarization, the best of the interpretive capabilities, mix it with the ability to actually get real data from systems or compute real things or look up real values, and then bring that all back together and serve it to the user in a way that adds value. To me, that's exactly where the big value is going to be. And as people are developing products, this is what's going to differentiate. But again, a large company shouldn't be building their own foundational model. They shouldn't necessarily be building, just broad generic apps. They ought to be focused on where is there super value within my specific industry and my specific business that we can get a competitive differentiator out of this. So some key thoughts to wrap up with, right? AI has been successfully integrated into products across many industries already. And there's also many new data and AI-based products that are hitting the market. This is a trend that's going to continue, and it's actually pretty exciting. There are some important concepts to account for with your deployments. We talked through a number of things such as the context, such as the ethics for different settings. And there's also big misperceptions. I spent a lot of time around the hallucinations and why those are a feature and not a bug, but a feature that you can in fact manage through a variety of techniques. And then again, the mixing of real data with AI output is where that differentiation is going to be. And that's where I encourage anybody here to focus on. And with that, I've just got a little page here with some information on me and links to my link to my website if you'd like to learn more. And with that, I hope you have a great show. Thank you.